In this video we will be making the calculations for a basic combination circuit. The first thing we want to do is fill in our known values, which I have already done. Our total voltage and the 4 resistor values. The first calculation that I would like to make for this circuit is total resistance. In order to do this, I'm going to have to redraw the circuit 2 times. If I look at the construction of the circuit, I can see that R1 and R4 are on the main branch of the circuit. R2 and R3 are in parallel with one another. So when I do my redraw, I'm going to have R1 still by itself at the top. I'm going to have R4 still by itself at the bottom. I'm not going to do anything with those two yet. But I can see that R2 and R3 are in parallel with one another. So I'm going to use my reciprocal formula for total resistance in parallel to calculate the equivalent resistance of R2 and of R3. So I'm going to reciprocate these 2 resistors and get this value here of 200 ohms. This leaves me with 3 resistors in series. In order to get the total resistance, I'll just follow the series rule for total resistance. So I'll just add these 3 together to get RT. So adding R1, R2, 3, and R4 together gives me a total resistance of 450 ohms. 150 plus 200 plus 150, 450 total ohms of resistance for this circuit. So I can put that value in the total resistance blank. Now that I've got total voltage and total resistance, I can calculate my total current using Ohm's law. 18 volts divided by 450 k ohms gives me 40 milliamps. Once I have my total current of 40 milliamps, just by looking at the construction of the circuit and looking at what is on the main branch of this circuit, I can figure out that my current, which leaves this negative post of my power supply here, all of that current must flow through R4. When it gets to point B, the current will divide. But this tells me that my I4, which corresponds to R4, must also be 40 milliamps because R4 is on the main branch. So this would also be 40 milliamps. Current's going to split. Some's going to go up this branch through R2. Some's going to go up this branch through R3. But it's all going to come back together at point A, and all of it has to flow through R1 to get back home. So it's going to come out, it's going to split. It's going to go up this way, but it's all going to come back together at A because there's only one way to get from A back home. So this tells me that I1, which corresponds to R1, is also going to be 40 milliamps. Now that I have I1 and R1, I can calculate V1 using Ohm's law, 6 volts, and I can calculate V4 using Ohm's law, 40 milliamps times 100 ohms, which tells me 4 volts. Now if this was an ordinary parallel circuit, and there was no R4, and there was no R1, and you just had 2 resistors here, in parallel with your voltage source, our parallel voltage rule tells us that both of these would have 18 volts across them because voltage stays the same in parallel. But due to the existence of R1 and R4, all of the voltage cannot be across R2 and R3. So R1 is going to drop some voltage and R4 is going to drop some voltage. And whatever's left over will be across R2 and R3. And we could write that equation out like this. V2 and V3 are going to be the same. So V2 is going to equal V3, and they're both going to equal the VT minus V1 plus V4. So we can just do the subtraction here to figure that out. So the 18 volts of VT minus the 6 volts consumed at V1 and the 4 volts consumed at V4 gives me my V of 2, 8 volts, and my V of 3 of 8 volts, and they're both going to be the same voltage. Why is that? Because voltage stays the same in parallel. Once again, I've got 2 out of 3 here, 2 out of 3 here, so I can solve for I2, and I2 would be 26.7 milliamps, and I3 would be 13.3 milliamps. Now that I've got all of these values calculated, I can find my PT using the power formula. PT is equal to IT times VT, so PT is going to be 720 milliwatts. P1 is going to equal I1 times V1, which is going to be 240 milliwatts. I can follow that same process to find all of my powers. So P2 is going to be 214 milliwatts, P3 is going to be 106 milliwatts, and P4 is going to be 160 milliwatts.